Good morning. Let's finish section 4.1, the antiderivative. Okay, so remember the indefinite integral. That's what this is known as, or referred to as. What is the answer to the indefinite integral? This is our antiderivative. And what does the antiderivative represent? The general solution to a differential equation. So starting with the derivative, we can find a function that has the given derivative. So today we'll look at initial conditions and particular solutions. So if we're given one piece of information that we refer to as an initial condition about the original function, then we can find the value of c from the general solution. Find the particular solution to the differential equation. Particular solution, you're going to be finding c. Any solution to a differential equation, you're going to need to use the integral. So what do? Collect the x's together, and then we're going to integrate. The integral of dy would give us y. Using the power rule, add 1 to the exponent, divide by the nu. So we have x to the 8th all over 2 plus c. Now, anytime you evaluate an indefinite integral, you always need the plus c with the antiderivative. So we need the general solution, but now look at this information that's given. So when x equals 0, we're told y equals 4. So let's place that information into the general solution. It gives us a value for c, and whenever you're asked for the particular solution, give the exact function with the given information. So after the first lesson, the antiderivative, we stopped here at plus c. Now we can determine the value of c. So this is the general. This is the particular. Same directions, find the particular solution. Now we have y. What function has a derivative of sine, negative cosine of t, plus c? Remember, every single antiderivative can be checked using the derivative. Derivative of negative cosine would be positive sine. Derivative of c is 0. Now take the initial condition and plug it in. You don't know what the cosine of 2 is. It doesn't really lend itself to a nice answer. But that's the value of c. So going back to the general solution and plugging in that value of c, we've seen this often. Trig doesn't always give us a nice answer, but it's an answer nonetheless. Okay, so let's think of the relationship between position, velocity, and acceleration. We know that the first derivative of the position function gives us the velocity function. The first derivative of velocity, which is the second derivative of the position function, gives us acceleration. So position to velocity acceleration, they're related with the derivative. What if, however, we know something about the acceleration and we want to find the velocity function? So now the integral of the acceleration function gives us the velocity function. And the integral of the velocity function gives us the position function. And this uses the property that we know velocity is the rate of change of position. So if we are going to integrate the derivative of position, these are inverses of each other, so they cancel each other out, and we're just left with the function plus c. Likewise here, acceleration is the rate of change of the velocity function. So if we integrate the derivative, these functions are inverses of each other, and we're just left with the velocity and then plus our constant. So now the new relationship, if we started at acceleration and wish to find velocity and position, that's the integral instead of the derivative. I sort of hate to say go backwards, but position to velocity to acceleration we derive. Acceleration to velocity to position we integrate. So a car is accelerating at a rate of negative 12 feet per second squared. Find the velocity of the car at time t. And I missed a part of this. At t is equal to 0, the velocity of the car is 96 feet per second. So this is an initial condition, so we're going to be able to find a particular solution. What does that mean? We'll be able to solve for c. Alright, so the integral of the acceleration function will give us the velocity function. That's what the question is asking for. Units will be able to guide your answer as well. Integral of negative 12 is negative 12t plus c. That is our velocity function. Now plug in our initial condition. At time t is equal to 0, the velocity is 96. C is equal to 96. So the velocity at any time t so it's the same rules. Integrate, substitute in the particular condition, but now we're just giving it a name. Okay, find an equation for f. Given f double prime is this polynomial, f prime of 1 equals 0, and f prime of 1 equals 4. Okay, we want to get all the way back to f. We're starting at the second derivative. So the integral of the second derivative is going to give us the first derivative. And then the integral of the first derivative is going to give us the function f. Notice that we're given a condition about the first derivative and the original function, so we'll be able to find c at each step. So the integral of x cubed minus 2x plus 1, using the power rule, add 1, divide by the new exponent, add 1, divide by the new exponent. So the antiderivative of f double prime would give us f prime. Now let's plug in our information. When x equals 1, y equals 0, 1/4 minus 1 plus 1 plus c. So c equals negative 1/4. So now when we want to find f of x, we're going to integrate f prime, x to the 4th over 4, minus x squared, plus x, minus 1/4. Power rule, add 1, divide by the new exponent, add 1, divide by the new exponent, add 1, divide by the new exponent, minus 1/4 x plus c. So this is f of x. And now using our initial condition into f of x, when x equals 1, y equals 4, so your homework, find c and give the equation for f of x. So we have the antiderivative, the general solution. Use these initial conditions, and for homework I want you to find the function f of x by plugging in those values and solving for c.